Hello everyone, welcome to my YouTube channel. Myself Gagan, currently pursuing second year in Sri Venkateswara College of Engineering. Today we are going to discuss about volume integrals and its applications. We are going to discuss about what is volume integrals, application of volume integrals in fluid mechanics, application of volume integrals in heat transfer, application of volume integrals in electromagnetics, application of volume integral in mechanics, importance of volume integrals in engineering design, challenges using of volume integrals, advancement of volume integral techniques, future of volume integrals in engineering, and conclusion part. We are going to discuss about what is volume integrals. Volume integrals are the fundamental concept in engineering application used to calculate the amount of quantity within the three-dimensional space. These are the integrals are defined as a limit of sum of infinitesimal volumes, each multiplied by the volume of quantity being integrated over that volume. In simple terms, volume integrals allow the engineers to calculate the total amount of quantity such as mass, energy, and a given region of space. The significance of the volume integrals in engineering applications cannot be overstated. They are used extensively in fluid mechanics, heat transfer, electromagnetics, and mechanics, among other fields. For example, in fluid mechanics, the volume integrals can be used to calculate the flow of rate of fluid through a given region of space. In heat transfer, they can use it to calculate the amount of heat transferred to the solid object. In electromagnet, they are used to calculate the electric or magnetic field strengthened at any point in space. Application of volume integrals in fluid mechanics. Volume integrals are the powerful tool for analyzing the fluid mechanics in engineering application. By integrating over the volume of fluid, engineers can calculate the important properties such as fluid velocity and fluid pressure. For an example, in aerodynamics, volume integrals used to analyze the flow of air over the aircraft wings. By calculating the lift force generated by the wing, engineers can design more efficient and effective aircraft. In other real-world application of volume integrals in fluid mechanics, in the design of water treatment systems. By integrating over the volume of water tank, engineers can calculate the rate at which the impurities are removed from the water. The information can be critical for designing a effective water treatment system that met the regulator standard and ensure the public safety. Application of volume integrals in heat transfer. Volume integral is essential tool in analyzing heat transfer of engineering applications. By integrating over the three-dimensional region, we can determine the net heat transfer into or out of region. This allows to analyze the complex systems such as engines, heat exchangers, and refrigerator systems. For example, in the design of car engine, volume integrals can be used to analyze the heat transfer between the engine block and surrounding air. By determining the net heat transfer, the engineers can optimize the design to increase efficiency and reduce waste heat. Additionally, the volume integrals can be used to analyze the heat transfer in materials such as metals and ceramics, which is crucial for designing the high performance components. Application of the volume integrals in electromagnetics. Volume integrals are the essential tool in analyzing electromagnetic fields in engineering application. By integrating over a volume, engineers can determine the total electric or magnetic flux passing through the surface. This information is critical in designing and optimizing the system that rely on the electromagnetic fields, such as antennas, motors, and generators. On real-world example, the use of volume integrals in the electromagnetic is in design of MRI scan machines. The machines use a strong magnetic fields to image the inside of the human body. The engineers must carefully design the magnets to ensure that the magnetic field is in uniform and strong enough to produce a clear images. Volume integrals are used to calculate the total magnetic flux passing through the coils of the magnet, which is essential in determining the strength of the magnetic field. Applications of volume integrals in mechanics. Volume integrals are the essential tool for analyzing the mechanical system in engineering application. By integrating over a three-dimensional region, the engineers can calculate the important properties such as mass, center of mass, moment of inertia. For an example, volume integrals can be used to determine the mass of solid object with non-uniform density by integrating the density function over the object's volume. The information is crucial for designing the structures that can be withstand the various load and forces. In other application, the volume integrals in mechanics is in the analysis of fluid flow around objects. Engineers can use the volume integrals to calculate the drag force on the object by integrating the pressure over the surface. This information is useful for designing the streamlined shapes that minimize the drag and improve the efficiency. Here we are going to discuss about importance of volume integrals in engineering design. Volume integrals play a crucial role in design process of engineering system. By using volume integrals, engineers are able to calculate the important parameters such as mass, center of gravity, moment of inertia. The parameters are essential for designing systems that are safe, efficient, and reliable. For an example, consider the design of an aircraft wing. In order to ensure the wing is stable and that can withstand the force of flight, engineers must calculate its moments of inertia. This involves using the volume integrals to determine the distribution of mass throughout the wing. Without this information, it could be impossible to design a wing that meets the necessary safety standards. We are going to discuss about challenges in using of volume integrals. One of the main challenge of engineers face when the using of volume integrals in engineering application is determining the appropriate coordinate system to the use. Different coordinate system may be more suitable for the different types of problems, and choosing the wrong one lead to the incorrect results. For an example, fluid mechanics, the cylinder coordinates are often used to describe the flow around the circular cylinder, while spherical coordinates may be more appropriate for analyzing the flow around a sphere. Another challenge is dealing with the complex geometrics in many cases. It is difficult or impossible to find the analytical expression for a shape of the volume being analyzed. This requires the use of numerical methods such as finite element analysis or computational fluid dynamics, which can be computational intensive and time collapsing. Additionally, the errors can be introduced if the discriminatization used in this method. It is not fine enough to accurately capture the geometry of the volume. Future of volume integrals in engineering. As the technology continues to advance, the potential application of the volume integrals in engineering are limitless. One of the possible future of application in the field of biomedical engineering, where the volume integrals could be used to analyze the flow of fluids in the human body and improve the and improve the medical treatments. Another potential future of application in the development of smart cities. Volume integrals could be used to analyze the and optimize the flow of traffic, water, and energy throughout the city, leading to more efficient and sustainable urban environments. Conclusion. In conclusion, we have explored the various applications of volume integrals in engineering, from fluid mechanics to electromagnetics, heat transfer to mechanics. Volume integrals play the crucial role analyzing and designing the complex system. systems. By integrating over the three-dimensional volumes, the engineers are able to gain the insights into the behavior of the systems that would be otherwise be impossible to obtain. Despite the changes that comes with the using of volume integrals, such as complexity and computational intensity, they remain an indispensable tool for engineering design and analysis. Thank you guys for watching this video. Please like, share and subscribe. Take care. See you in the next video.